Okay, so this is visible, right? Can anybody just confirm?
Yes, sir.
Yes, sir.
No. Okay. Okay, so yesterday we started with Gressenham's algorithms. So we have seen the complexity of drawing a line on the computer screen or more on the like a raster graphics devices. So where we discussed about what is the difference between vector graphics and raster graphics. So vector graphics is more of a mathematical statement or sequential command um, where actually you specify the mathematical operations and so these type of examples are kind of like PDF files, EPS files, SVG files, and raster graphics is more on pixel manipulations, where actually you paint your pixels or turn it on and off and things like this. And the examples are like typical image formats like JPEG, BMP, TIFF, or these type of formats. Okay, so the problem we were seeing that for drawing a line on the screen, you have to turn the pixels on, or you have to paint the pixels depending on the color of the line actually. So sometimes what happens if you try to draw a line like this, it's like a continuous line. But since it's going through the grid of pixels, so you have to choose pixels that approximates the line. So approximation means we are talking about the discrete approximation here. Because this red line actually, although it looks solid ideally, but sometimes it's not possible because depending on the slope of the line, well, if it's a horizontal line, then it's not a problem because you just paint the pixels like sequentially. But when it's not horizontal or not vertical, it has some inclination. So you have to identify the pixels that has a close approximation of the line. So that's why we are trying to minimize the discrete approximation and the ideal line, the distance between these two in some geometrical sense. So some of the qualities that we want to achieve here is that the line should look continuous, it should have uniform thickness, and also it should be accurate enough. And of course the speed, because this is a simple operation and we need to have a good speed for this algorithm. Okay. So we started with seeing some examples of how things actually look like with the simple line drawing equation. So this is like y is equal to mx plus b is the so this is a simple line equation, and we try to draw a line between 2 points, x1, y1, and x2, y2. So that's why we fitted the equation with these two set of points, so y1 and y2. And then from this equation, we just equate them with just simple algebra, and basically we get this formula: delta y is equal to m delta x. Okay. So now what we are trying to do is to take a sample line. So this is the line equation that we are considering here for this example. Y is equal to 1/3 x plus 2/3. And then we try to see if we increment x by discrete values, then how the y values will look like. And where actually we started with x is equal to 1, 2, 3, 4, and we have got some y values. And since pixels have like a discrete, basically you cannot go like a floating point numbers here. So eventually we have to round it up. So that's why we have seen the round of values for the y values. And we have seen that if m is greater than 1, then the line won't be solid because the delta y will be much larger than the delta x values. So what happens actually for these type of cases is okay, but here when delta y is greater than delta x, you have to choose a y that is not lying in any pixel grid in particular, and you have to choose which one actually to choose. Y1 is yi or yi plus 1, or which one is closer. Okay, and this is particularly true for we are considering a special case here for a slope m from 0 to 1. Okay, and considering that delta is equal to 1. Okay, so this is xi, and xi plus 1 is the next point we are considering. So that means, so this is xi, and this is xi plus 1, I plus 2, I plus 3, and so on and so on. And here actually we have use the convention that d1 is the distance between our computed y value and the previous pixel. That means y and y1, the distance between y and y1, and our computed value and the next pixel. That means y and yi plus 1. So this is d2. And then we try to fit d1 and d2 and find the expression. So basically the line equation is y is equal to mx plus b, so you simply put x is equal to xi plus 1. and eventually try to find the distance between y minus y1 and here. So d2, and what is d2? So d2 is equal to the same expression we get from here. So that means yi plus 1 minus y. Okay. And what we are trying to do is to take a difference between d1 and d2. Okay. And while doing this difference, so somewhere we have got xi plus 1 and we replaced with the discrete pixel values. That means xi plus 1 is equal to xi plus 1, and we have got this expression. Okay. So we call this expression delta x d1 minus d2. This is as pi. Okay. And we try to see if pi is less than 0 or is greater than is equal to 0. So less than 0 means d1 is closer. So that means we will choose yi, and if it's greater than is equal to 0, we choose yi plus 1. Okay. So now we have to find the expression for p1 and pi and pi plus 1 and so on and so on. Okay. So that's what we will derive now. Okay. So so that means if pi is less than 0, then basically what happens? So if pi is less than 0 means, so in this case basically d1 is less than d2, right? And in the otherwise case, d1 is greater than or equal to d2. Okay. So that means yi is closer if d1 is less than d2, and yi plus 1 is closer if d1 is greater than d2. All right. Okay, so now we try to rewrite the equation of pi in terms of xi plus 1 and yi plus 1. Okay, so let's see how it's looking like. So let's rewrite the equation of pi in terms of xi plus 1 and yi plus 1. Okay. So pi plus 1. So basically simply put, so this is pi, right? So this is the equation of pi. So we simply put I is equal to I plus 1 here. Okay? So then it will look like, so 2 delta y x I plus 1, so that means c1 plus 2 delta y minus, so we would write this thing first, minus 2 delta x y I plus 1 minus, sorry, plus 2 delta y, yes. Yes, plus 2 delta y plus delta x, okay, to d minus 1. It's just a simplifying equation. Okay. And we find the difference between pi plus 1 minus pi. Okay, so what will be this? So what was pi? Pi is here, and pi plus 1 is this one. So just take a difference. So that means 2 delta y x I plus 1 minus xi minus 2 delta x yi plus 1 minus yi, okay, plus 2 delta y minus 2 delta y, okay, and plus it's the same actually, 2d minus 1 minus delta x, 2d minus 1. So basically these terms get cancelled. Okay. So now what we have seen here, xi plus 1 is equal to xi plus 1, right? So if we put it here, so what will happen? So that means pi plus 1 minus pi is equal to, so that means this is equal to 1, so that means 2 delta y minus 2 delta x yi plus 1 minus y. Okay, let's take this equation as, because we will need this, so let's call it equation 1. Okay. Okay, so that means so now we have an iterative procedure or iterative mechanism to determine which pixel to turn on and progress on the x-axis by the step of 1. So that means eventually you start with pixel 1, and then eventually find this pi plus 1 values, and eventually go through like 1 2 3 4 5 6 7 8 and like so on and so on. Okay, so let's start the iteration by some initial value. So let's start with uh, like p1, because first iteration we have to complete, right? So without p1 we cannot do anything. Okay, so if we try to compute p1, so what will be p1? So p1 we can get from the expression of pi, right? From the expression of pi we can get it from here. Okay, so p1 will be 2 delta y x1. So that means from here 2 delta y x instead of I could just put 1. Okay, okay, minus 2 delta x y1 plus 2 delta y plus delta x of 2b minus 1. It's as simple as that. So let's divide it by delta x. Okay, so that means p1 by delta x will be 2 delta y by delta x of x1. So delta x is getting cancelled here. It's 2y1 plus 2 delta y by delta x plus 2b minus 1. Okay. So what is delta y by delta x? It's m, right? 2m x1 minus 2y1 plus 2m plus 2b minus 1. Okay. So this is equal to, so just separate 2 m x1 minus y1 plus b plus 2m minus 1. It's just rearranging the terms, that's it, nothing else. Okay, so that means, so p1 by delta x is equal to mx minus y1 plus b plus, so if I just write it like this, delta x to delta y minus delta x. Okay, so let's call it equation. Let's call it equation 2. It's just nothing but a simple rearranging of terms and nothing else. Okay, so that means we have got P1 and we have got an expression of P1 by delta S that we'll see that actually how to use it. So basically we have to write the expression of P1 in terms of delta Y and delta X. So let's see how can we get there. So now, so we have like a Y1 is equal to mx1 plus b, right? So that means mx1 minus y1 plus b is equal to 0. So put it in equation 2. So that means mx1 minus y1 plus b. So this term basically, that's why I computed it here like this. Okay, so we put it 0 here. Sorry. Okay, so that means what will happen? So then p1 is equal to, so see that here there is a delta x here. Okay, so that means if I multiply this here, so this delta x will get cancelled. So that means this term gets cancelled out. So this is equal to 0, and we only get this 2 delta y minus delta x. So that means 2 delta y minus delta x by delta x, and there is another delta x that was there, so delta x. So that means p1 is equal to 2 delta y minus delta x. So this is the final expression for p1. Okay, let's call it 3 or whatever. Okay, so that means we have got a concrete expression for p1. So how to start the iteration that we were trying to do. Okay, so that means p1, if we have the delta x and delta y values, then we can compute p1 without any problem. Okay, now let's use the green color. Okay, so if pi is less than 0, then which one should we choose, yi or yi plus 1? From here, if pi is yi, okay. So yi is used for yi plus 1. And why this? Because we have got some y value, or previously we had, let's say, yi, and next is yi plus 1. So basically, for the case of yi plus 1, so we will be using yi, that means the one below this one, right? So that means what will happen, so p I plus 1 minus pi is equal to, okay, what was the value? Pi plus 1 minus 2 delta y minus 2 delta x. What was here? Yi plus 1 minus yi. Okay, but the thing is that this yi plus 1 and yi, so what we are considering, we are using yi instead of yi plus 1. So what should be of this term? What should be the value for this term in this case? Because if my, let's say, this is my computed y value, okay, and we are choosing yi for this, so doesn't it get coincided? So that means this is equal to 0, right? Because we are choosing yi, right? So that means what will be the expression for p1? Pi plus 1 minus pi is equal to 2 delta y, because this is equal to 0, because we have chosen yi in this case. So that means pi plus 1 is equal to pi plus 2 delta y. So this is my expression for pi plus 1. So this is the expression for pi plus 1 pi is less than 0. Oh, sorry. Yes, exactly. So we also have to consider the case if pi is greater than or equal to 0. So then what will be the pixel for this case? I plus 1?
Yes, sir.
Yes, I plus 1 is used. Okay. So that means in that case, so what will happen? So yi plus 1 means yi plus 1 minus yi is equal to 1, right? Because you have like one difference here in that case. So previously we were choosing this one for the case of y, so that means these two coincide, it gets 0. And in the next case we choose the next one, so that means the difference of these two pixels is 1. So that means we have this expression. Okay, so that means what happens? So in this case, pi plus 1 is equal to pi plus, so pi plus 1 is equal to pi plus 2 delta y minus 2 delta x, and this is coming from where? This is coming from here actually. Okay, so yi plus 1 minus y is equal to 1, and that's why. So basically pi plus 1 is equal to pi plus 2 delta y minus 2 delta x. So this is our final equation. That's it. So we started with computing p1. So our goal was to find the y which is closer to yi or yi plus 1. So for this we computed the difference of d1 and d2 and tell the difference as pi. Then we start with p1 and we have got an expression for p1 eventually. And after getting p1 we have to determine if it's less than 0 or is greater than or equal to 0. So if it's less than 0, so that means the first one, or the yi, will be chosen, and that's why we take the difference as 0, because yi has merged here, And in the next case, basically we choose yi plus 1 and the difference is 1, and eventually we get here. So that's all we need for the drawing a line like this, where basically m is between 0 and 1. Okay, so if we try to write the algorithm for this, so what will be the step-by-step procedure for this? So if we try to write the algorithm, so how it will look like? Okay, so first of all, you have so we assume that we are trying to draw a line between 2 points, x1 y1 and x2 y2. So what will be the first step? Which plot should we do? Can you tell the very first step? To draw a line between x1 y1 and x2 y2, what should be my first plot, the very first plot, without doing any calculation? No? Nothing?
Take the values of x1 and x1,
Yeah,
y1.
yeah, plot x1 y1, exactly. So to plot x1 y1, you don't need to do anything else, right? So that means the first step will be plot x1 y1. That's it. Okay, so in the next case, what we'll try to do, so this is my x, and we try to increment this, right? So basically 1, 2, 3, 4, and so on and so on. So what we'll do is that we run a loop. So that will go from, let's call it I is equal to x1 to x2, because we are going from x1 to x2 by step of 1. Right? So then we traverse like this. Okay. So what will be the initial case? So in the initial case, if I is equal to 1, then what happens? For I is equal to 1, which one did we compute? Which one did you compute? Anybody? For I is equal to 1. How about this one? P1. We computed this for P1 because we started the iteration here. Let's start with P1, right? So if I is equal to 1, so we compute value of P1, right? Then P1 is equal to 2 delta y minus delta x, right? 2 delta y minus delta x. Okay. Else, we have to consider two cases, right? So if pi is less than 0, then what will be the expression? This one for pi plus 1. Okay. So that means pi plus 1. Sorry, actually pi, we don't write it here like pi plus 1. So we still write as p1 just for convenience. So pi is equal to pi plus 2 delta y. Why? Because you see here, uh, pi plus 1 is equal to pi plus delta y, but in this case for the convention we are using the same. So basically we increment this by 2 delta y. So that's why we write pi is equal to pi plus 2 delta y. Oh, sorry. Okay, and else, so pi will be this one, pi plus 2 delta y minus 2 delta x, pi plus 2 delta y minus 2 delta x. Okay, and so in the first case, so what happened? So in the first case, so let's say this was my y value, and in the first case we chose this one. So that's why you don't need to increment the y value, right? Because y is already here. But when you choose yi plus 1, so then you have to increment the y value, otherwise it won't increase. So that means in this case, actually, along with this, you have to increment the y value. Right? Otherwise, it will start at the same point and it will never increase, right? So that's it, nothing else. So then basically you end the if, and then what should we write here? Any other increment after this? So we started with x value. So although it depends on the like convention of the programming language, but we have to increment x also. If we don't assume that actually it's you can skip it because it's you can already include it in the loop statement. You can write it here, and then basically you just draw the point. Draw. Okay. This one. Y1. Okay. Actually x. Into x1 to x2. Actually, it should be xi. And then basically you end the if and that's it. So every time we go by increment of x one by one and compute the corresponding y value. And start with x is equal to p I is equal to 1. In every case, you just compute two things. That's it. Okay. So this was pretty much all about the Bresenham's line drawing algorithm for a line with slope between 0 and 1. Um, Actually, there are other cases as well, and I leave it up to you. And you can also see it in the web. There are actually plenty of things to do this. So yes. So basically, there are other cases as well. So this is basically symmetric case. So we are considering a line like this actually between 0 to 1. Okay, and if we consider the other quadrants, so there are 7 other cases as well, but you can just do the same. You don't have to redo the calculations over and over again. You just exchange the value of delta x and delta y and incrementing the coordinates accordingly. So that's I leave it for homework, and you can also look it at the web. There are many other tutorials for doing this. So make sure that you practice this, because in your next assignment, the first assignment, I will try to give something interesting with the Bresenham line drawing algorithm, and it's nice. It will be nice if you understand it correctly. Okay. So, any question from Bresenham's line drawing algorithm? No. No? Okay.
Sir, x2 value will be given in the question, isn't it, sir?
Yes, you have to tell that we want to draw a line between x1 y1 and x2 y2. So that will be actually the so otherwise, I mean, how can you draw a line? I mean, you have to specify the beginning coordinate and the end coordinate, and then you have to draw a line between these two. So
And any other information like slope and other things?
now slope you have to compute, because let's say if I try to let's say I give you some coordinates, okay, and that coordinate, if you plot it, so the line looks like this, or the line looks like this or something. So you just compute the slope by delta y by delta x, and then basically have a case study of m is, if m is lying between 0 to 1, then do this, or else between 1 to infinity, then do this, and so on and so on. So basically you have to rewrite the same thing for the other slope as well, and just have a switch case between these, all these kind of things. You can look at the web for like a naive implementation of Bresenham. This is already in the web, so this will be nice for your understanding. Also, what I suggest is that you try to do things on your own. So that means this algorithm is very simple actually. So you try to do some hands-in exercise with plotting this simple line, and then try to experiment with other cases as well, and then you will understand it correctly. Bresenham is not complicated at all, so you won't find it very difficult. Okay. Okay. So actually, there are other line drawing algorithms as well. This is called DDA and all these kind of things. But we are not covering this because there are plenty of other things to do. So we started with Bresenham. In fact, Bresenham has many other algorithms as well. So this algorithm was developed in 1960s, I think around 1965, when Bresenham was working at IBM. Eventually, this algorithm was not published or was not released due to some copyright issues. So after 5 years or something, it was published, and then eventually it became public. Mm. So from then, actually, it has been used a lot. So there, these days, there are certain things beyond Bresenham's line drawing, because Bresenham has also some drawbacks. It's not the perfect one. There has been some other algorithms as well, but that not that much. So this has still been considered as one of the finest algorithm for line drawing. Although there are some better approximations these days available in the computer community. Okay. Okay, so similar to the line drawing algorithm, there is also Bresenham's circle drawing algorithm. So this is even much simpler than this, or I would say that this is similar to the previous. So let's quickly see the circle drawing algorithm. Okay. Okay. So what is the equation of a circle centered at origin?
X square plus y square equal to 0.
Yes. X square plus y square is equal to r square. Okay. So because of the symmetry, we can compute only one quadrant of the circle. Okay. So if we compute only one, like a quadrant, like this part, so basically all the other parts are basically symmetry. It's similar to the line drawing that you interchange the delta x and delta y values. Okay. So actually you don't have to, you can compute only 1/8 of the coordinate. If you compute only the 1/8, and rest of the things are basically, it's just a symmetry. Okay. So let's assume that center XYC is equal to 0, 0. Okay. And we start here. We start here. Okay. And then eventually go like this. Okay. And okay, let's draw it properly. So basically, maybe I'll just erase this. It's a little bit messy. Okay. Okay. So we start at here, and let's call this coordinate as current as so this coordinate is basically 0 r, right? Because r is the radius. Okay. And the current pixel we'll consider it as xi yi. Okay. So this is the current pixel. Okay. So that means if we go in this direction, then the next pixel will be either xi plus 1 comma yi, or xi plus 1 comma yi minus 1, right? Because if this pixel is here, so either x is incremented, so this is x-axis and this is y-axis. Okay? So x is incremented by 1 and y remains the same, or you turn a little bit down like here. So that means basically x is 1 and also y is decreasing by 1. So that's the one case we consider, and other cases are symmetric as well, as I mentioned. Okay. Okay. So the exact y value will be like that, means y square is equal to r square minus xi plus 1 whole square from here. Okay. Xi is already incremented because we are moving in this direction. This is r. Okay. So like the previous one, we also consider the distances d1 and d2 as we did in the case of Bresenham. Okay. So we compute d1 as yi square minus y square, and d2 as y square minus yi minus 1 whole square. this one, right? yi minus y and yi minus y square minus 1. Okay. So what is this value? This value is yi square minus, what is y square? Yes, from here, r square minus xi plus 1 square. Okay. And what will be the value of this? Y square means y square minus xi plus 1 whole square minus y minus 1 whole square. Okay. These were reason. Okay. Again, in just like the previous one, we compute pi. So pi is d1 minus d2. You just do the simple algebra. So that means yi square minus r square plus, so here is the negative sign is plus, so xi plus 1 whole square minus r square. Okay. Plus xi plus 1 whole square minus y minus 1 whole square. Okay. So that means xi plus 1, there are two of them. 2 xi plus 1 whole square plus yi square, this one. And there are two r squares, 2r square. Okay, so this is equal to pi. It's called equation 1. Okay. It's similar to the Bresenham's algorithm. So either we see which pixel to choose, since we are moving in the clockwise like this direction. So next, in the next pixel, xi will be incremented for sure. So that's why in both cases is xi plus 1. So either y can increment or y cannot increment, or y remains the same. Okay. So that's why we choose d1 and d2 to determine which pixel to choose. Okay? So that's why we compute d1 and d2 as in the previous case, and eventually compute the difference between them and tell it pi. Okay. Again, similar to the line drawing case. So what happens if pi is less than 0? Then choose yi for yi plus 1. And else choose what we'll choose? We will choose for y I plus 1. Which one should we choose here? Can you tell? Can you tell it from here? Come on. So if it's less than 0, we choose this one. And if it's greater than or equal to 0, which one should we choose? What should be the work coordinate? Nobody? Okay, you guys are sleeping maybe? I don't know. Okay, so let me write down yi minus 1, because we are considering yi minus 1 here. Okay. So yi minus 1 will be chosen for this case. Okay. So in this case, we have to do the same thing like previous. So pi plus 1 we have to compute, right? Okay. So we compute pi plus 1 here again. So pi plus 1 is equal to, so for pi plus 1, what we do is put I is equal to I plus 1 here in this expression. Okay. So xi plus 1. So what is xi? So in this case, xi plus 1 is equal to what? Like the previous case in Besenham, isn't it incremented by 1? No? So that means 2xi plus 1 here, and the plus 1 was already there, square, and plus for yi we write yi plus 1, y plus 1 square. Okay, and what else? Minus 2r square, right? Okay, so basically you just simplify this expression to xi plus 1 whole square. So a plus b whole square, basically we simply do the formula. Okay, plus 2ab for xi plus 1 plus 2 plus yi plus 1 square is the same. Okay. Sorry, a plus 2 plus yi plus 1 square, yes, plus yi plus 1 minus 1 square minus 2r square. Okay. Okay, so now let's try to write it in terms of pi. So we try to write in terms of pi. Okay. So then what will happen? So what was the expression for pi here? Pi is equal to 2ix plus 1 square plus y square minus r square. So can we put the pi expression here again? So let's write it down here. So what was pi? Pi is equal to 2xi plus 1 whole square plus yi square minus 2r square plus y square minus 2r square. So we try to plug it in here. So then what will happen? So that means this will be like so if you consider this term and this term and try to put it the things from here, so then it will look like pi minus yi square minus yi minus 1 whole square. Okay, and rest of the terms are basically pretty much the same. So we just write 2 plus 4xi plus 1 plus y I plus 1 whole square plus, that's it. Okay, so what we did is we simply compute the pi from the expression of d1 minus d2, and then try to determine the cases of like if yi is closer or yi minus 1 is closer. So for this we just substitute the value from previous equation of pi into this equation. Okay. Okay. So now it's again like the simple algebraic like a simplification, nothing special about it. So just put it. So pi minus yi square. Okay, there is another yi square here minus yi square. Okay, plus 2yi minus 1 plus 2 plus 4xi plus plus 4 yi plus 1 square 1 square 2yi plus 1 plus 1. Is it okay? You just simplify this, nothing else. Okay. So here is plus 1 minus 1 gets cancelled out, and there are 2yi squares, and also there are 2yi plus 1 squares. Okay. So this is equal to then pi plus, so 4xi, let's say write it here, 4xi plus, so 2 plus 4 6, okay, plus 2 of y I plus 1 square, here 2y square, so minus y square, minus 2 of y I plus 1 minus yi. That's it. So this is the expression for pi plus 1. Here, let's call it equation 2. Okay. So this is just a simple algebraic equation, right? So that means y I plus 1 is either yi or yi minus 1, depending on the sign of pi. Okay, right? Any question here?
Sir,
Yes.
how means yi plus 1 when x is increasing, the second point how it will yi minus 1 means in a image, if you can show, sir, maybe I missed it. Last slide,
The last line.
sir.
Okay, so that means here, so maybe I can draw like this is your circle, so this is yi, right? And the circle, so what happens, either you go here or you go here. So if you go here, then y is not changing, right? Y value is remaining the same. But if you go a bit like turning, so then y is decreasing, right? So there can be two cases, either yi remains the same or yi gets yi minus 1. But x is always increasing because this is your x, so you are going to the next one, right? Do you get the point or no?
Yes, sir, yes, I understood.
Okay, okay. So basically that's why we are considering this direction. So if you consider other direction, then it will be different. So then x will be decreasing and y is either the same or also decreasing. So if I consider, let's say from here, so what will happen? Let's say here this is 0 and minus r, the coordinate. And if you try to decrease it here, so that means next x will be I plus 1 for sure, and the y value can either remain the same, yi, or it will be increasing, that means yi plus 1, because we are turning upwards like this. Okay, so it's this type of, that's why I said that this is a symmetric case. Basically, if you do only one, then the rest of the things are basically pretty much done automatically.
Yes, sir, thank you, sir.
Okay. Okay, so so this is pretty much the same. So if we try to write the algorithm for this, so it's similar as the previous one. Okay, so we begin. Okay, so let's say x is equal to 0 and y is equal to r, because we started here. Okay, so in the first case, p is equal to so what was this equation of pi like this? So let's write it here again. Okay, so what was my equation here? Pi is equal to 2 xi plus 1 square yi square plus r square minus 2r square. Okay, so for the case of p, so basically what we have to do is we have to put x is equal to 0 and y is equal to r in this equation to get the first case, right? So then what will happen? So that means P1, so we are trying to compute basically P1 or P, or we simply call it P, okay? So P is equal to, so that means 2 plus r square plus r square minus 2r plus 1 minus 2r square. That means there are 2r square and here is 2r square. They get cancelled. That means 2 plus 1, 3, 3 minus 2r. So that means P is equal to 3 minus 2r. So this is my starting point, okay? So now basically we run loop where y is x is less than y, okay? So for covering the case, so basically you plot xy, okay? I increment x, okay? So now consider the cases of pi less than 0 and greater than 0 like the previous. So that means if p is less than 0, then what happens? Now we'll need this equation. This equation we'll need, okay? So I will repeat it here for convenience. So in this case, basically, so that means pi plus 1 is equal to pi plus 4xi plus 6 plus 2 of I plus 1 minus I square minus 2 of minus yi. Okay. So in this case, actually, if pi is less than 0, so what we do? So we just put yi plus 1 is equal to yi. Okay, because we are choosing the first case less than 0. So that means in this case, what happens? We do it like this. So that means p plus 4x plus 6 plus 2 of, no, sorry, 4x plus 6 plus, actually, it should be 0 actually, plus 0, it means 4x plus 6. That's it. So that means in this case, p is equal to p plus 4x plus 6, okay, and else, so else case means, so we consider the other y, that means yi plus 1 is equal to yi minus 1 in the same equation, and for that case, how it will look like? So that means p plus 4x plus 6 plus 2 multiplied by yi square minus 2yi plus 1 minus yi square plus 2. Okay, so these two get cancelled. That means p plus 4x plus 6 minus 4yi plus 2 plus 2 equal to p plus 4 x minus y plus 10. It's normal operations, okay? So we copy the same thing here. But here in this case, y is actually decreasing, right? So that means we have to decrease the y as well. And then p plus is equal to 4 multiplied by x minus y plus 10. That's it. And you end the if. And plot xy and y and basically n. That's it. So this is pretty much, so you start with your coordinate where you want to start, and then eventually complete the first case of P1, and to get to the P1 you have to give it the starting coordinate. So if you start from here, so then in this equation what will be your first coordinate? So instead of this one, what should I give here if I start from at this point?
Y equal to 0.
And x is equal to?
R.
Yes, so it's R0. So if you put R0, then basically you start from here and eventually you go from like this. So you consider two cases, x is less than y or greater than y, and nothing else. And rest of the things are pretty much the same as the previous one. Okay, so this is all about the Bresenham's circle drawing algorithm, and there are other geometric primitives as well. If we get time later in the course, then I can show you like ellipse drawing and other types of drawings, but these are like very close to the one you have just seen for the line and the circle case. So just replace with the ellipse equation and nothing else. Okay, so we stop here for the Bresenham drawing case, and from the I think next Wednesday is a holiday, so we get only Thursday and Friday. So we'll start doing transformations lectures from the next week, or maybe it will be covered in two classes, might be. And the lab, the tutorial session will start now. So for those who cannot attend the lab, you can attend the tutorial, although it's just 1 hour. So I will just end the class here and then start a new session for the lab, and then you can join. Otherwise, rest of you maybe we start at 2. Okay. So if you have any question, let me know. Otherwise, we stop here. Okay. Okay. Thank you very much. See you later.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.